everybody. Today I'm going to be showing you a topic from algebra that is used in algebra at least, and is used in geometry very heavily, and this is the Pythagorean Theorem, a relatively simple but intuitive concept. So I'm going to draw a right triangle here. I'm sorry for that bad of a drawing, but let's imagine that we have a right triangle here, and a right angle is represented somewhat like that. And so, with this, we're going to have this is just a triangle with a 90-degree angle, and we call this a right triangle. And it's going to have a side length. Let's say this side length has length A. I'm going to say this one has B, and we're going to say this one has C. So, using this, I'm going to show you the equation for the Pythagorean theorem right now, and I'm going to actually write this out because I feel like this is important and my handwriting is not adequate. So, a squared plus b squared is equal to c squared. So I'm going to put parentheses so you guys can comprehend it a bit easier, hopefully. And so, okay, yeah, that's a good enough spot. So, the Pythagorean theorem basically is a squared plus b squared equals c squared. Now, what does this mean? That means if I'm given any two, if you give me any two sides, if you give me, oh, I am so sorry there. If you give me any two sides of a right triangle, I can solve for the other one. And let me try to cross some of this stuff out. And let me just fix it really quick. Oh no. Okay. So that means if I have anything, let's say somebody gives me the values for A and B, I can use this equation to solve for C. Likewise, I can also, if somebody gives me C and B, I can solve for A as well. And so that's the importance of this equation. You can solve for any side of a right triangle, assuming you are given the other two. And you can use this equation to also find, you can use this in many other applications as well. So, what I'm going to show right now is, right, so I'm going to give you a problem of which to do, and okay, I'll just move over here, give myself a bit more space. You can use the equation for reference right there if in case you forget, but after a while this should become a very common equation because it's very widely used in not only high school, but it has many other applications as well. And let me just draw this a bit more clear. Okay, so now that we have this, I should fix that. Okay, so we have a right triangle here, and I'm going to give you that this side right here is 3, and this side right here is 4. And I'm going to ask you to solve for this, which I'll label as C, just to make things easy. And before you can try solving this, but before I go and solve it, let me just give you the breakdown of just a general right triangle, some terms that are commonly used. Each of these sides right here, so A and B, I'll call them sides A and B. These sides right here are commonly known as the legs of the right triangle, and they are the shorter sides of the right triangle. So out of the three sides, these two are the shortest. It doesn't matter which one is shorter between A and B, it's just that they're not the longest. So, and C, by the way, is the longest. And C is longer. So C is longer than A. I'm going to write some rules here for right triangles. C is also greater than B. And one thing that maybe not everybody catches on initially is that it's very similar in format to the Pythagorean theorem, but it has differences. That C is greater than or equal to A plus B. And I said in similar in format because this is a squared plus b squared equals c squared. This is a plus b is greater than or equal to c. That means if you add up the lengths for a and b, it has to be greater than or equal to the length of c. So using those three rules, let's check if we're going to solve this using the Pythagorean theorem. Then we're going to see if it fits all these three rules for being a right triangle. Now, obviously, with the Pythagorean theorem, we're implying that it is, but we're seeing if that it was. We're basically checking if it was correct to use the Pythagorean theorem, or what value would make it correct for being a right triangle. So we have 3 as a side length here. We have 4 as a side length here, and c. We're going to try to solve for c. So let's put it into the Pythagorean theorem. And this right here is the hypotenuse. C is going to be the hypotenuse for us. So we have A and B. We're given A and B, and we're going to solve for C. So let's do that. And so we're going to go 3 squared plus 4 squared is equal to C squared. And we don't know what C is. What is this alert? Oh. Okay. Oh. Well, okay. I'll do that soon. Thanks for the reminder, I guess. I got a reminder. I got a little notification. Sorry, guys. So, here we have, so if you start solving, you get 9 plus 16, and some of you might already know that 9 plus 16 is 25. Some of you might notice that in this problem in particular is pretty easy. So 9 plus 16 said 25. Add that. And we got c squared. You can take the square root of each side. These things cancel, and this also you have to take the square root of. So you get 5 is equal to c. Oh, sorry for the high pitch there. And we can check if we put, let's say we have 5 is equal to c. C is 5. A, we're going to say, let's say it's 3. So 5 is greater than 3. Likewise, it's also greater than 4. With this rule right here, we can check. So 3 plus 4 is 7. C is 5. Is 7 greater than or equal to 5? Yes, it is. So we can confirm that this is a right triangle, and we use the Pythagorean theorem to solve for all sides. Thanks for watching.